Do remote access kind of login. See your Windows Remote Desktop.
I've not managed to do that.
Okay, I know you do that. Do remote access kind of login. See your Windows Remote Desktop.
I've not managed to do that.
Okay, I know you do that. Do remote access kind of login. See your Windows Remote Desktop.
I've not managed to do that.
Okay, I know you do that. Do remote access kind of login. See your Windows Remote Desktop.
Yeah, that's like Alright, are we recording right now?
Yeah.
Alright. Alright, are we recording right now? He is their software, from what I understand. He is their software, right? Yeah, I don't have any idea how you would do that. Yeah. He is their software. Right. I don't have any idea how you would do that. He is their software. Right. Yeah, I don't know. Yeah, I don't know. There's probably other ports too. Right, yeah. There's probably other ports that are open too that you can hijack. There's probably other ports too. Right, yeah. There's probably other ports that are open too that you can hijack. Nah, I did ODU. Okay. Right. Nah, I did ODU. Okay. Right. All right, we're gonna get started. Welcome to the Java users group here for NSWCDD. We are actually live on YouTube right now, just so everybody knows. So you can go back and watch us respond to your comments. I don't know how well it'll be heard from the audience when you guys say stuff. But if you want to, yeah, I'm trying to repeat the questions. But if you want to see what happened again, relive this next hour and a half or so, then you can go back and watch. So, real quick, we're going to do a welcome and introduction. We're going to talk about our mission statement and values. We're going to talk about our meeting schedule, go over some news, and then we're going to do an intro to Java 9 modules, which I think is going to be great. So, we're glad you're here. If this is your first time, please sign the attendance sheet. Real quick, we're going to do a welcome and introduction. We're going to talk about our mission statement and values. And put your email on it so we can add you to the mailing list. Go over some news, and then we're going to do an intro. Who are we? Mike Kelly's doing the main lesson this month, and he's a software developer from B24, and I'm Andy Neprosh from A21. And if you guys have come to any Jug meetings before this, you've heard one or the other of us speak, most likely. So that's who we are. Why did we organize the Jug for NSWCDD? Well, we wanted to have a place where we could discuss common issues related to Java and to meet people who are doing similar work and potentially increase software reuse and improve development skills. And also we put it together because we knew it'd be a good vehicle for us to go to Java 1, which succeeded. We did it several times. So our mission statement, we're trying to provide Java software developer community that improves developer productivity, reduces duplication of effort, and fosters innovation. We want our values are we want to master Java fundamentals. We want to work on software development best practices and exchange ideas and foster innovation. And we do take these seriously, and we do talk about them in our board of directors meetings. So, and we try to do the lessons around these things. As you know, the meeting is the first Tuesday of the month, unless otherwise noted, which is pretty rare, usually January, and it's at 1 o'clock. So, to the Java news. Java 9 is still planned for July 27th. If you guys, for those of you who missed last month, here's just a quick recap of some stuff. Oracle has a developer's guide out there, so if you're switching over to it, you should probably check that out. There's a substantial amount of things being deprecated in it, and some of those things being deprecated will be removed eventually, so you probably want to pay close attention to that. And it's going to have a new garbage collector. And actually, on the garbage collector, I was reading more on that just the other day. Now they're talking about possibly making an optional garbage collector that only does allocation. So it's not really a garbage collector anymore at that point, because it doesn't clean any memory up. It only does allocation, so that would be great for testers. It would suck for the rest of us because we're going to have to remember to clean up all of our stuff, or else memory leaks galore. But the testers who want to know, what are you really doing, that's good news for them. So that's a possible additional thing that will be added sometime in the next couple of years if they decide to do it. So there's a project called Trinity that's being voted on right now. I think the voting ends on the 5th, which is Friday. I think that's when it ends. Is the 5th. It's either the 5th or the 4th. So it's I don't know why they would turn this one down. Honestly, I mean it's right now. Last I checked, it's about 50-50. I'm very much in support of it. I don't know why people are against it. I can't understand why anybody would not want this. But basically, what it is it makes so that streams can access the processor better, so they can make better use of the accelerators, like the math accelerators and stuff in your processor, which basically means, so using streams is already really fast. I don't know how many of you have done that, but it actually is quite substantially faster than things we've had before Streams came along. And with the parallel, especially because it takes advantage of multiple cores and whatnot, well, this will make it even faster. So I don't know why people are opposed to it, but some are. Also, Oracle's talking about doing other JVM improvements, and they're really big on Java, which the funny thing is I don't really get the hype for this. But, so Java on Java, they want the JVM to actually be written in Java. At least that's the best I can understand what they're talking about. They want it to be largely written in Java so that you're running Java on Java. Supposedly that's going to make it faster and such. I don't really, knowing assembly and C and other languages, I don't really understand how that is going to offer much improvement. But Oracle seems to think it will. I kind of think it's an Oracle sales pitch. I don't know. Maybe I'm wrong. Yeah, I guess straight from Java to binary. So sounds cool. Okay, I'm not opposed to it, but I don't really get it. That's me. So another thing, how many of you in here have heard of Jenkins and used Jenkins or have used Jenkins in any way? So Jenkins is actually, it's a really nice tool. Sounds cool. Okay, I'm not opposed to it. And it's gotten a lot nicer with this Blue Ocean interface. It's made it a lot more user friendly for people that want to access it and see what it does. But I'm actually thinking about, I have a friend who knows this really well and does it, and I'm thinking about trying to convince him to come in and give a lesson on it, so you guys can see just how powerful it is. But it's a build tool. So what it does is every time you go to build your like in the IDE, like in NetBeans, when you go to build your software, your program, it will automatically do like a whole bunch of tasks, whatever tasks you have it set up to do. Like my friend who uses it checks the code into two different CM tools, because we have a crappy CM tool that we're forced to use, and then Git, which we all kind of use because we hate the crappy CM tool. So we use that and then just tell them that we only use the official one, Synergy. Do all of you feel the Synergy pain? Nobody else feels the Synergy pain. You guys are so lucky. Because we have a crappy CM tool that we're forced to use, and then Git, which we all kind of use because so it automatically checks it into Synergy, which is no easy feat. And Git, it does the compile on it, and it runs unit tests on it, and it does a few other things. It does code coverage on it, and it keeps track of all the results of all these every single time you do that, and it builds pretty charts for abandonment for you to look at. It's a really nice tool, and as I said, the Blue Ocean, because I tried using it like years ago, and I was like, well, this is nice, but it's kind of funky and not easy to use. But then when I saw my friend using it, I was like, wow, it's changed a lot. Well, now that I read this news article, it's clear to me that he's been using the pre-release of Blue Ocean, and it's much nicer. So if that's something you're interested in, you should definitely check it out. It will make your life a lot easier on the build side if you do a lot of those tasks. And as I said, I'm going to try and get somebody to come in and give a lesson on that. So watch for that. In other news, Finalize is being deprecated. Oracle hasn't said yet if it's going to be removed or not. They did say it won't be removed immediately, so it's not going to be deprecated with removal in 9, but it is going to be deprecated. Oracle says that it causes a lot of problems, which I can see nobody really knows if it runs or not, so it needs to go. So it's being deprecated, so if you use Finalize a lot, you should be aware of that. Also, So, for those of you who might be interested, Java 1 is a big conference every year. This year it's the first week in October out in San Francisco. It's not like most conferences. You might think of it's really kind of a large training event. You have literally at any given time like 40, 50 sessions going on that you can choose from to go to. And Oracle is usually very tight-lipped, so it's hard getting news for stuff like this. But if you go to their conferences, because you paid them money, they like to talk to you a lot more. So it's the best place to get information on what's going on with Java. And it's a very fun event. It's very and Oracle is usually very. It's weird when you're there because there's Java 1 and then there's Oracle Open World. And Oracle Open World is all suits and ties and dresses. And Java 1 is all t-shirts and jeans, occasionally shorts. And it's kind of cold. It's San Francisco in the summertime or in October, if you haven't been there. But it's weird. The two worlds are right next to each other, and just seeing the difference. But it's, a lot of the events that they have are mixed, and you get to like meet a lot of people and hobnob and stuff like that. So, anyways, if you would like to go there, one easy way to make sure you do is to speak. Well, if you want to speak, you have until May 7th, so Sunday, to put in your proposal to speak. I've put in, so the good thing about Java 1 too is it's not like other conferences. You don't need to get a public release, like he's saying, because they don't ask for an essay or anything like that. They ask you to provide an example of you, a video example of you presenting. So if you don't have one of those, you can just do it in front of your cell phone at home in the mirror or something. And other than that, the most they ask for is an abstract, which they have limited to like 600 characters or something like that. So there's nothing long enough that you need to actually get a public release. There's nothing that you would be putting any kind of information in. They don't ask for anything more than the abstract on what you're going to be talking about. That's very short and abstract. So I've talked to the public release people, and they've said in the past, you don't need public release for anything like that. So you would be putting any kind of information in. They don't ask for anything more than the abstract on what you're going to be talking about. Yeah, I have two, but the abstract was, it was when it was longer. When I went and showed them, they kept telling me, why are you having me look at this? So you guys can try to get public release if you want. It is kind of a pain, but I found that it's not necessary for this. Yeah, I have two. So, it was when it was longer. If you would like to do it, you can ask either Mike or myself. We both successfully have done this. We've both spoken at Java 1 several times in the past. So you can ask one of us about it, and we'll be happy to walk you through it. But like I said, it's pretty easy. You just have to answer a crap ton of questions, because Oracle is a database company, so they do it more database-like. So instead of writing some big thing that somebody's got to read and select you from, you answer a whole bunch of small questions through what a database narrows you down automatically to what they want to look at. So it's not so bad, but it does still take a little bit of time. But anyways, they were due like in April sometime, then it got pushed to midnight last night. Well, they pushed it again only for Java 1 to May 7th, so you still have time to get papers in if you would like to speak. So now I'm going to turn the time over to Mike to give lesson on intro to modeling. But anyways, they were due like in April sometime, when it got pushed to midnight last night. Well, they pushed it again only for Java 1 to May 7th, so you still have time.
Yeah, crazy. Okay, go back in. All right, I want to see everything. Okay, excellent. All right, well, thanks for coming out. I'm going to be talking about Java 9 modules and kind of how you can get started using them, and some of the new features and gotchas and stuff like that. I got to say, playing around with the modules has been pretty fun. I think it's going to be a really awesome feature and a much needed feature for Java. It's just going to take us a while to get used to because it's just not something that we are accustomed to doing with Java. So here's the agenda for today. I'm going to first talk about how do you use Java 9 without modules, okay? So this answers the question, is this going to totally break my code when I try to compile it, okay? So thankfully, they didn't totally screw us over with that. There is a way that you can go ahead and bypass a lot of the stuff. So then I'll talk about modules, why is this a good thing for Java? Couple of, things problems it solves and benefits that it gives and so forth. And then I'll get into the actual Java platform modules. And I'll try to give some examples along the way so you can see the actual code. And I'm going to be flipping screens a lot, so hopefully you'll be able to follow me without too much trouble. And there's a few things that I'll touch on as well, mixing modular and non-modular code, and also a few command line options that are really, I think, going to come in handy during the transition phase when you're trying to actually move code over to be compatible with Java 9. All right, so without modules, say you've just got your normal code that you've been working on for the past few years, you can actually use Java 9 with that as is without moving any of your code into modules. The way that they have designed the module system is that it's opt-in, meaning that they're not going to require you to migrate all of your stuff over to modules. It's kind of designed so that you can gradually move your code into a modular design as you get more comfortable with it and as you have time and so forth. The class path is still around and it's still usable, but there are some requirements there that I'll mention. There are a few command line switches which you're going to want to know about. First one's called add modules. The way that they have redesigned the Java development kit, or the JVM as well, is they've broken it all into modules itself. So the JVM is actually a modular design now as well. And so most of the code is contained in this java.se. When I say contained, I mean that it's basically bundled. But there are cases where if you're doing like Java EE stuff or something along those lines, you might have to add an additional module. Add exports is an important one. So let's say that you're one of those people that depends on one of those internal APIs, like the X509 security one or something like that, even though they've been telling us not to use them for however many years. If you do, there's a way around it. You can add this add exports flag and just specify what the package is, and it'll actually allow you to still access it. The one that they just released, which is not even in the JDK yet because they haven't actually coded it in. I think it came out of Devoxx. I think the Devoxx conference was this past week, and they must have had a lot of complaints or something because they added this sort of global kill switch for Java 9, meaning it's called permit illegal access, which basically is going to say, all right, well, forget all the protections that modules give you, just allow you to access whatever the heck you want. Okay, so this is kind of the initial bypass that is going to be on Java 9, okay? So this is basically calming all those people that are like, oh my gosh, you're going to break all my code. I tried to compile it with Java 9 and it totally broke it. What are you doing? So I'm sure that they had a lot of that. So this is going to be available, but it's only going to be available in Java 9, meaning that in Java 10, this will not be available. I'm talking about this permit illegal access. So meaning that, hey, we're going to buy you some time, but eventually you're going to have to actually, fix those problems. Okay, so code compiled and loaded outside of a module ends up in what they're calling the unnamed module. It's sort of like he who must not be named, Voldemort. Never mind. That's what I thought when I saw unnamed, but perhaps that's not what you think of. But basically, it's sort of a catch-all for any code that has not been modularized. It gets stuck in this unnamed module, and by default, the unnamed module basically makes everything in it readable, meaning that anybody can access stuff in the unnamed module. It makes use of the class path. It by default is dependent on this java.se, which is what you would normally, today think of as the Java runtime environment. And it does require you to set the class path at runtime. So it's the same way that you've always set it, -cp or -class path. Now, the only thing that's a gotcha here is you can't mix a modular code cannot access the unnamed module. So it's like you have part of your code in a module or have modularized it, and then everything else is kind of in a non-modularized state, then you can't actually reference that unnamed module. But there's, of course, the way around of it using this permit illegal access flag that kind of just, allows you to access whatever. Now, the one thing that I will say, though, is that I'm just talking about, let's say you have a particular code base and you're compiling a set of Java code into a single jar. If you have part of that code base that's modularized and another part that isn't, then that's where the problem is. Because as I'll show you later, is that if you have your unmodularized code in a separate jar, Java 9 handles that and assumes that's basically a module itself. So it sort of like puts a wrapper around it for you, making it so that it seems like each external jar that you have is its own module. So they really put in a lot of things to make it easier for us to work with it. It's just going to take a little bit of getting used to. Okay, so let me just switch over here. So Java 9 without modules. Let's see. Okay, so here's a non-modular project here, just a real simple thing. I've got 3 classes, caller, main, and responder. It's not it's not modularized. It's just regular old code. And let's see if I can get in here. See. All right, so non-mod project list. All right, so let me see if I can move this here. So Java 9-d build source star.java. So that'll run the compiler, no issues there. So handles without any issues your standard, whatever your existing code is. Now this is a very simple project, doesn't do anything special, but just to show you that if you've got code that is not modularized, a lot of times you can just run Java 9 compiler and it will have no issues at all. Jump back to my presentation. All right. Okay, so why modules? Why did they do this to us? Why did Oracle and the Java team decide that it was time that we felt this pain of modules? Well, for the longest time, since Java's inception, the concept of a reusable component was a class. So that was kind of the basis of the Java language. If you wanted to reuse code, you were reusing classes. And that made sense for smaller applications. If you only have a few, 10, 15 classes, okay, that makes sense. You might even have everything in a single package and, no issues. But the problem arises when you start to build enterprise-level software and you're building APIs, building libraries for other people to use, and there's certain parts of your code that are meant to be internal, meaning that they're just implementation classes. They're not meant for anybody to actually access and play around with. And even so, there's sort of that fear that if they do play around with it, well, they could use it in the wrong way. They could break something. That's where the issues really start to rise. And then it becomes an issue of Well, how do we control that level of access? How do we make a module or a package a reusable component, so that if I've got my external facing packages and I have my internal packages? Well, the current Java access protections that we are used to, your standard public, private, protected, and package level, they're insufficient to do this. I mean, if you make a class public, it's public. I mean, there's nothing you can do. I mean, it's either public or it's not. And if it's public, everybody can see it, even if you don't want them to. So there's no way to conceal that. And so what modules do is it allows you to actually specify which of your packages are going to be visible to the users of your API or anybody who's consuming whatever services you're providing. So it allows you to have a lot better control over how your APIs are being used, so that if you specify a certain set of classes that are your data types that you want everybody to be able to use, you can safely use internal classes that maybe have certain assumptions attached to them that you don't have to worry about communicating, because nobody's ever going to be able to access those. So it really gives you a lot more freedom to design things how you want and not have to worry about, okay, well, if I change this internal class, is that going to break everybody who's dependent on this? Well, if they can't see it, they can't depend on it. And so it's a much better way of designing larger systems. So what's a module? Module is a cohesive set of functionalities with a well-defined API for external access. So that's the key thing, a well-defined API. Could be that you specified a set of interfaces, a few set of classes, but that you've got it well documented, and it's usually not a huge number of classes. The module only exposes the API, meaning that you've got some internal stuff that only you know about. You're not going to expose that. You only expose the API, so that if you decide, okay, well, I really should have used something different in that implementation. Well, you can go and change that and not worry about somebody else's code breaking, because they can't depend on it. A good example of the shortcomings of the old way of doing things without module is look no further than the sun.star and com.sun packages that are part of the Java library, and how many people have used those over the years. And even with all the deprecation warnings and all that stuff, people still were dependent on them. And those were not meant to be ever used outside of the internal JVM. So it does happen even if you have good documentation and so forth. So you really need a way to control that access. So some of the core tenets of modularization: strong encapsulation, the ability to hide the internals of what's going on, the well-defined interfaces, only allowing people to use what you want them to use, and explicit dependencies. So when you look at a module, you can see exactly what it's dependent on. I mean, I've had a lot of situations where I get a piece of Java code, and I go to compile it, and it doesn't compile. I get a bunch of errors. I'm like, what is this thing dependent on, And so I'm going through, and I'm trying to find, like, okay, well, what library is it, and I end up looking at all the imports and stuff like that. And I'm like, okay, how do you do that, And if you happen to have like some sort of class file, or not a class file, but the file that basically lists all the dependencies in a jar. I'm blanking on the name. Please help me out. What's that? Manifest. Thank you. Okay. Yeah. So if you look at the manifest, you're going to get a huge list of like jars and stuff, and it's really hard to figure out. So basically, if you want to figure out, well, what exactly is this module dependent on? It's not an easy thing usually. So that modules give you that specificity to say, okay, it's depending on these 5 libraries. All right. So the Java 9 library, or JVM, has been broken up into 26 different modules. Apparently, this was like a monumental effort, which is why the release of Java 9 took so long, or I guess the release of Project Jigsaw. I mean, I guess it was originally supposed to come out in Java 7, and they delayed it to Java 8, didn't make it, so it's in Java 9. Well, apparently this was not an easy task. I mean, you think about like a monumental refactoring task, you know, if you got like a huge code base and then you got to suddenly move everything around without breaking everything, it's not an easy thing. And so that's why they kept having to delay things. It introduces Java 9 introduces the native concept of modules into the Java language and runtime, and allows you to do all these things that I just described with the strong encapsulation and only exposing packages that you want to be seen externally. And also allows you to express those dependencies between modules. So with Java 9, if you want to generate a dependency graph, it is super easy. I mean, you could very easily just write a little script. They've actually already got it in the new nightly builds of NetBeans. You can just hit a button and it'll actually show you all of the dependencies that a module has. And this is kind of an eye chart. I guess it's not too bad, but this is a small part of the Java language dependency graph. There's actually, you know, some other stuff over here, but basically everything depends on java.base. So every module depends on java.base by default. It's sort of how like every class depends on object in Java. Well, every module depends on java.base, whether you specify it or not. And so you can see there's a lot of different modules that have been specified out here. Java SE depends on, you know, pretty much everything. The only thing off to the right here is like Java EE related stuff and some serialization for Java XML or for XML. So they did a really nice job. I mean, think about 26 modules. That's really not that much considering the volume of code that makes up Java. So what are the benefits that we get from this JPMS, which is, I'll be referring to that Java Platform Module System? So you get a reliable configuration, meaning that you're not going to have these runtimes class not found errors that all of us are used to seeing, because at compile time, it's going to tell you exactly what's missing, because it knows what the dependencies. And at the same time, if you try to run it, it's going to also check that dependency graph and tell you right off the bat, well, you're missing, you know, this module or that module. So you know as soon as you run a modularized Java application, before anything happens, it's going to spit out and tell you whether or not you have any problems. You're not going to be halfway through using it, hit a button, and get like a big stack trace. So that's a huge improvement in my mind, because you have that confidence that you're not going to have those sort of deployment issues. The strong encapsulation, scalable development, having things modularized gives you a better sense of better boundaries between the modules. You know, good boundaries make for good neighbors, allows you to parallelize your development efforts a little bit better. And security, the ability to hide different parts of the code is going to help you to, yes?
The security in particular, so you said, you're obviously talking about the module system right now. You said if you had unmodular code, it would be loaded into a module by default.
Right.
An unnamed module, would the security still impact that? Like specifically the node core reflection of private members?
Okay, so the question is, if you've got an external jar that gets automatically wrapped into a module, is that going to improve that security of that?
Is security going to be enforced?
Yeah, it's not for those, because it's essentially if you have an external jar that you're using that is not modularized, it is essentially exporting everything. It's exporting all the packages, and so you're not going to be able to hide anything with that. But by default, though, in terms of reflection, and I think I mentioned that later in the briefing. But with reflection, there's actually it's sort of a perpendicular kind of axis that deals with reflection. By default, you can only do reflection on public members. So I guess now it's pretty easy to do reflection on a class and you can see even the private members and everything. Well, that's disabled in Java 9 unless you specifically say open this package, meaning that I'm opening it up for complete reflection. So in that sense, an external jar is going to benefit in that if you have an external jar that's wrapped in a module, if you have to actually say, I want this particular package of that module to be open. And so that actually could improve the security. But I will tell you that I haven't like played around with that particular feature that much because Java 9 is kind of a moving target right now. So the ability to play around with some of these stuff, especially in the IDEs, has been a little bit limited. But anyway, I think that's probably something you'll want to investigate a little further. And optimization. This is the other thing. How many people have like had you're starting a Java application and you're waiting, and then finally it comes up. It's like, why did it take so long to load? All I've got is this little Hello World program. Well, in the past, I mean, you had to load everything. I mean, you had to load the entire Java runtime environment. I mean, so even stuff that you didn't need, even if you were just using system out print line, you had to load Java XML, you had to load Corba. I mean, is anybody using Corba anymore? I imagine over in A department they are. But still, there's a lot of things that most people aren't using. Okay, yeah. So anyway, I guess there's a lot of things that most people aren't using. So why should you load them if you're not using them, right? That's stupid. So with Java 9, with the module system, since you know exactly what your dependencies are, you don't have to load any of that stuff. You only load what you're using. So if you're only using like, a couple of different modules, if you're only using Java base, that's the only thing that gets loaded. And so what you get are faster launch times with Java. So better performance, less waiting, and we all know very, very impatient people. Impatient and lazy, that's what programmers are. And so we like things to be fast. What's that?
Is that a smaller footprint also?
Yes, smaller footprint and memory as well, because you're not having to load all this unnecessary stuff. All right, so I kind of mentioned some of this stuff. All modules depend on java.base implicitly. You don't have to specify that because that would get pretty annoying if you had to keep doing that. And the java.base includes pretty much the stuff that you use in almost every Java application. I mean, you've got your java.lang, java.io, .net, and Java utils, so like your collection classes and so forth. So you notice Swing is not in there, JavaFX is not in there. Those are in separate modules, so you don't have to pull in anything that you don't want if you're just doing like a command line application or something. Modules are discovered on the module path. So they've given us a new path. So we used to have class path, and class path we hated because it was just a total mess. So now there's the module path, which basically specifies all of the different modules that we have access to. And modules cannot access anything on the class path. So you can sort of imagine this sort of invisible line where you got things that are using the class path up on the top and things that are using the module path on the bottom, and they can't talk to one another. And so the only way to get modules to talk to those non-modular components is basically to stick a wrapper around them and pull them down so they're on the module path. So I mentioned earlier that if you have an external jar, Java automatically wraps that up in its own little module container. That's so that it can pull it down from the class path and put it on the module path so that you can access it with modular code. So they do that for you, which I'm really thankful for, because I was really worried about that. Like, how is that all going to work out? But it sounds like a pretty decent solution. So modules are discovered on the module path. And modules are specified using this new file called moduleinfo.java. So we've probably seen packageinfo.java before, but this is a new addition, and this is basically where all of your module information lives. This is where you specify your dependencies and what you're exporting, what are you making public, and also the name of your module. It lives in it's a globally unique module name, so that's one sort of catch that you need to make sure that when you're naming your modules, you want to give them something that's fairly unique. Yes, sir.
Your Java Lang IO and Net, is that one module?
Yes, Java Lang, Java IO, Java.net, and Java Util are all in Java.base. And I mentioned with that, you guys remember that tree or that dependency graph, everything is dependent by default on Java.base. Yeah, so you don't have to actually say, hey, I need to pull in Java.io, or you'll get it by default. Okay, so when you're naming your modules, you got to give them something that's unique. There really isn't any specified naming convention at this point, but a lot of people are adopting kind of the org.nitmil or mil.navy. Whatever the reverse address notation for naming the modules, and that might be a good thing to do, because it seems like that's probably the direction it's going to go, since nobody has really given any official guidance on it. The module.info file, it actually lives at the top level directory. So if you've got your source code and you've got say your first package is my package, and then you have a bunch of packages below that, your module.info or your module info lives just above your top level package, and it's not actually in any package itself. It's just sitting at the very top of your source tree. It declares the required external packages that it requires, and declares which packages are visible to other modules using an exports command, and I'll have a couple examples of that. And also, I'll show this a little later as well. The way that you consume services is also handled by the module info. I don't know if any of you have ever used the service loader capability in Java. Maybe, maybe not. It's basically you've got an interface that's defined, and then you have maybe several possible implementations of that interface, but you don't want the consumers of that service to know about the actual implementations. That's what we call a service. Very common pattern in the NetBeans platform development, but it was integrated into Java, I think in maybe Java 7. Anyway, they have the service loader class to do that. Well, in Java 9, they make it even easier, because you can basically just specify whether or not you implement a service, or that if you consume a service as part of the module declaration. All right, so this is the module info. This is kind of an example here. So you've got module specified, that's a keyword, followed by your module name, which could be mil.navy.mycoolstuff.awesome or something to that effect. Something that is going to be unique. And this is an example of a requires. So this Java XML bind is actually outside of the java.se module. So it was part of Java EE, I guess. And so if you wanted to use that, you'd actually have to require it specifically. And as part of my code, if I say, hey, well, I want to export my package and make that visible to anybody who's going to be using my module, I would use this export command. So you can have multiple of these. You can have like 15 requires. You can have multiple exports just listed straight out. If I'm consuming a particular service, I can use this uses command here, keyword, and specify the service that I'm using. If I'm implementing a service, I can use provides with this format as well. And that's how I say, hey, I'm a provider of a particular service. And getting back to the reflection question, if I have a package that has data types that I'm using with like Hibernate or Spring or something like that, where they need to be able to have full reflection, then I would open that package to say, okay, I want other libraries, other modules to be able to have full reflective access on the classes in this package. So that's kind of all of the different combinations that you can have in a module. So it's pretty simple in terms of what you can actually specify, but it's pretty powerful as well. I mentioned the module name has to be unique and that there's no official naming convention, so just use the reverse DNS format. And talked about the open statement for reflection. All right, so let me.
ModuleInfo.java is the exact name though. It won't be whatever your module name is.
Right. It's always going to be called module-info.java. If you call it something else, it will not work. So, all right, let's look at an example module info. So I'm using the development version of NetBeans here because the current one doesn't actually support Java 9 yet to this degree. But the new version of NetBeans actually allows you to create a modular project. So you can actually go in and say, okay, I want to create a new module project, and go in and it will generate it for you. And then from here, I can add new modules. Yay. I like my module, right? So it will give you the ability to quickly do that and automatically generates the module info. Well, I already have an example module project created here, so let's just take a look at one. So here's what I'm calling an API module. So I've got one package called API and one that's called internal. So here's my module info file. You notice it's at the top of the source tree above both of my packages there. Open that up. Very simple. Nothing at the top, no package declaration or anything like that, like you'd have with a normal file. Just straight. The only thing in there is just module. So I got module. I'm not following the reverse DNS notation here, by the way. I'm just giving it a very simple name. Got my name, and I'm telling it, hey, I'm exporting API. Exporting the API package. So anybody who depends on this module, this API module, will be able to see all of the classes in API. So let's go to another one, which I'm calling Service Simple. And I'll just point out here too that in part of my API, I declared a service, which is just an interface. And it's just got some service method that I'm calling. So saying, hey, this is a particular type of service that can be implemented by providers and then consumed by other modules. So if I go into my service implementation here and look at my module info, here I've got my name, Service Simple, requires API module. So there it's saying, hey, I need to be able to access API module. And what can I access from API module? Only the things that it exports, which is the API. If it tries to pull in anything that hasn't been exported, it's not going to compile. So right there, you're getting that good encapsulation that's only allowing you to see things that you're supposed to see. Here's the declaration of my service implementation. So I'm saying, okay, my module here is providing this API.myService with this implementation. Now this service implementation, you notice it's not exported. So that means that nobody else outside the module can see it, but it will be available through the service loader. And so it's just specified right there. It used to be back with the older versions of Java, you would actually have to create like a text file that said, okay, well, I've provided these implementations. It was very error prone. You could easily screw something up, misspell something that wouldn't work. So this is a much better way of doing this. All right. So this guy doesn't export anything. So if somebody depends on Service Simple, they're not going to be able to actually use any imports on it. So let's go to test module here, which is my third module. All right, look at its module info. So it requires API module, and it uses API.myService. Notice it does not have a requires on the service impl. But as we'll see, it's actually going to indirectly use that implemented service. So you saw here then, you've got one guy that's saying, I'm providing the service, and then you got one guy that's saying, I'm using it. So now, if we go into just an example main function here, just a couple of examples. We've got an import statement. I'm pulling in stuff from the API package, which was exported. So, hey, yeah, that's nice. That works. If we say, all right, well, let me try to import my internal dot, yeah, it doesn't recognize that. You can't do it. It's not exported. So it actually will not even compile if you try to do it. So down here, I'm just using one of my API data types and invoking a method on the data type. No big deal. The magic and that I think is really cool is when you get into using the service loader. So here I'm saying I want to load a instance of my service, and this is just an interface. My service is an interface. Okay, so it actually goes out and pulls out, looks at the implementations that are available, which we know is our service impl class or service impl module, and it pulls it in, and then I can actually invoke that service method, and it will indirectly call that service implementation, even though our module knows nothing about it. So this is like an awesome way of decoupling things. You're basically accessing implementations of things without directly depending on them. So very powerful tool for designing decoupled architectures, and one that, like I say, NetBeans platform has been doing for a while. But it's good to see that they're actually putting it into the main language here.
So what would happen if you have multiple services?
If you have multiple services, you can actually iterate over them. I'm actually just looking at, so if I look at this service loader here, S loader, I've got some choices here. I can do find first. I can grab an iterator. I can even do a stream, say for each. So you can actually iterate over all of the providers. If there were actually more than one, and maybe as part of the service you had some type of name or some way of figuring out which ones.
Registering with a name or anything?
It could be, yeah. I mean, that could be. It's all depending on your how you'd specify the service.
The service loader class itself is a collection, or like a container.
Yes, yeah. So it basically goes out and figures and finds all of those implementations of a particular service and makes them available. But the thing is you don't have to actually have a direct dependency between the modules.
But so if I wanted to, that would be a way if I wanted to iterate through it, that's fine, right? Like so, but if I know I want specifically this implementation, not some other implementation, but that implementation isn't the one you implemented, isn't exported.
Right.
Can I still, will I be able to say like, hey, if it's not equals this?
Well, and that would be part of how you would design your service. I mean, I've got like one method here, but I could pretty easily, add some sort of additional method that allows me.
But you're not using reflection.
No.
You have to couple it through basically outside knowledge.
Right. So you could do it in a few different ways, but it would all be dependent on whatever problem you're trying to solve. I think if there could be some sort of predicate that you pass in that says, hey, tell me whether or not you meet this requirement. And there's lots of ways, but it would be part of your API though.
I mean, each service could return a quality of service. Like
Yes.
something we want, right? And then we can find the appropriate one.
Exactly.
So
But not
it'd
necessarily.
be good to be baked into the design.
Right.
Yeah.
Externally.
Yeah, I mean, I think in terms of like Whirlwind terrain providers or something like that. And Whirlwind provides a lot of different terrain models. Some of them are higher quality than others. And you basically just have to iterate through and say, give me the highest quality one if that's what I'm looking for. So that's part of the API design, but it's all very open, however you want to design it. And some of the challenges you run into are just, part of the nature you're trying to decouple things to prevent unnecessary knowledge between them. Okay, good questions though, good questions. Let me jump back to my present. What's that?
So do you have to?
I know, now it's telling me I have to implement that stupid method. What's up with that? Okay, that's module info. All right, so a little more on just the declaration dependencies and so forth. So there's this concept of being read that you might hear about if you're reading about Java 9. But in formal terms, package A is read by module B if it is exported by module A, and module B requires module A. So that's sort of represented by this diagram on the right here. So we've got module A that's exporting a particular package, and then module B requires module A, and by doing that, it automatically gets access to all of the exported packages in a module. So if a package isn't exported, it is inaccessible. So that means you cannot see it. So like public is no longer public as it used to be, all right? So that's might be something to get used to, that just because you have a public class, that does not mean that everybody is going to be able to see it. You actually have to export it as well. So within a module, though, your normal understanding of public, private, protected, that all goes. So within a module, everything is as it once was, and all that. So it only deals with going between modules that is the new understanding required.
Right, and also, and like you showed, you had to have a separate source directory within your project for each of your modules.
Yes. Right. Yeah. And so that's your modules will require a separate source directory because you can only have one module info per source. So
It'll be interesting to see how Eclipse implements that.
yeah, I'm thinking it's good that they made it opt-in because I think it's gonna probably take a while before people actually get a hang of it and actually are able to do this efficiently.
Do you have a default set of modules, that have certain functionality, or
Is there a set of default modules with?
basically that module? Do they have other modules that have certain functionality that you automatically just kind of stuff that I'm going to require this module?
Oh yes. So the question is, are there other modules other than Java-based that have other functionality? Yes. And I don't know if you noticed in that big dependency tree that I showed earlier, there were lots of other modules listed here that essentially contain different parts of the Java language library. So, for instance, if I was going to use some of the Java desktop functionality, I'd actually have to declare a dependency on Java desktop to pull that in. If I want to do Java FX, that's like another module I have to explicitly declare a dependency on. So that goes back to only loading what you need. I mean, why should I load Java FX if I'm not even using Java FX? So it's a trade-off, right? Because you have to do a little bit more work up front and understand the structure a little better. But at the same time, you're also getting a lot of optimization out of that, and also a much more maintainable code. Does that answer your question?
Yes, I understand.
No, that's cool. No problem. It's all new stuff here. All right, so how do you determine if something is readable, a particular package or class is readable? You want to ask yourself these questions here. So if class A, if module A, is that accessible for module B? For one, you have to make sure that the package that contains class A is exported. If it's not exported, you're not going to be able to see it. And also, does module B require that module A? So it's sort of a two-way pairing here. So if you've got a module that exports a package, but the one who wants to use it isn't requiring that module, it's not going to be able to read it. So you have to say, hey, I export this, and B, I require this. And that actually makes it a coupling. All right. And so basically public types and exported packages are accessible. So if you have, it's kind of what you would normally expect. So once it's once something is exported, your normal understanding of the access permissions apply. All right, and so I mentioned earlier, deep reflection is illegal by default unless you specifically declare a package is open. And so if you're using Hibernate or Spring or something that's actually doing reflection to determine, what fields are there and so forth to do serialization, you'll actually have to specify those packages as open. All right, module readability. I think I've pretty much kind of talked about that enough. Okay, so you've got existing code, you want to migrate to be modular. This is, you'll probably want to do this slowly, not all at once. But the first step in doing that is to run this JDEPS tool. This is a tool that comes with the Java, the JDK. And it's also included in Java 8, but apparently it's not the same as the one in Java 9. So don't run the one in Java 8, run the one in Java 9 to determine the actual dependencies. So this JDEPS tool will go through your code or your jars, whatever you have. It doesn't matter if they're binary or not. And it will spit out all of the dependencies, external dependencies. So if you have any dependencies on unsupported packages like com.sun or sun.star, it will tell you immediately. It will also tell you what third-party libraries it's dependent on. And it'll also tell you if your third-party libraries depend on com.sun or sun.star, which is probably a bigger issue, right? And if we do see these problems, then we can fix the unsupported dependencies in our code. And for the third-party libraries, we can just use a command line switch if we need to fix it, and just while they're trying to actually make their stuff modular. And then we create a module info file in the root directory, and then we declare the package that should be exported, and boom, we have a module. And I'll show you what that looks like. So here I've got a set of code that is not modular, my little 3 classes here. So I say, all right, I want to make this modular. So I go to my top level source folder here, module info.java. All right, so I create my module info.java, and so and I'll try to do this the way that's supposed to. Navy Dahlgren or something, or NSWC. My cool module. All right. So and it's underlining it here because it hasn't actually been updated to support the Java 9 features yet. But so that's I declared my module here. Now I just have to say which packages are public. So let's just say I want to make my org Kelly my package public. So I just do exports org Kelly my package think. That's it. So modularized. So that's all you got to do to make your code modularized in terms of adding new code. All right. So very little work in that regard. But it's really the making it, if you have other outside dependencies, that makes it a little bit more complicated. Okay. So so very easy to do in terms of adding new code, but you may have to play around with some command line switches to actually get it to compile. But from what I've seen, once the IDEs get up to speed, they're still kind of lagging a little bit, I think, just because they're literally like adding new stuff to the JDK, and so well, at least the command line switches, like the finishing touches. So by the time it comes out, you probably won't even have to think about much of this. It'll probably be in a GUI, and you can just drag and drop and say, okay, I'm going to do this, and it'll probably have a little light bulb where you click on it, and it'll automatically fix everything for you. But at least you'll kind of know what's going on in the back end a little bit better here. Okay, so I showed you the existing code migration, piece of cake. All right, so mixing modular and non-modular code. So I've got some code that's modular and some that is not. Let's say that I took my module that I just made and now I want to use Apache Commons or something to that effect. Well, as I mentioned earlier, the external jars are automatically wrapped in modules by the JDK. So if I'm using Apache Commons, it automatically will wrap that in a module wrapper, and then you can treat it as if it was an actual module. And the way that it does that, if I have a jar called commons-math, and followed by a version, well, it gets wrapped into a module called commons.math. You see what they did there? They just took the first text part of the jar name, and that becomes the module. So if I want to use that module, all I have to do is go into my little module definition here and say requires commons-math, and I'm done. So now I can access anything in that jar like I normally would. So, commons.math, my bad. Sorry about that. Getting senile. Yes, commons.math. So what it does, it replaces the dash with a dot. That's the only thing you need to know. But that's how the name gets created, essentially. Just automatically generates that. So from what I've seen in the IDEs right now, I've been trying to use it with NetBeans and some of the other IDEs as well. None of them seem to support this yet. So if you try it, it doesn't work. Don't be surprised. But that is technically, if you do it from the command line, it does work like this. So when it does wrap these modules or these jar files, it actually exports everything. So there aren't any private packages. You don't actually have to do any work to be able to access those packages in your jars. So very little work that you actually have to do other than just putting the requires there. Okay, and then like I showed, you can just then add the requires commons.math or whatever the name of the module is, and you're good to go. All right, so let's talk a little bit about the command line options and workarounds. Java add modules. If you, for example, your code that you are working with right now depends on Java XML bind, and your code is unmodularized. You don't have any modules in there. Well, if you try to run that code, it's not going to work. It's going to say, hey, I don't know what this Java XML bind thing is. What's going on? But that's because by default, when you compile non-modularized code and run it, it's dependent on the java.se module, which is also pulling in a lot of stuff. But it's not pulling in Java XML.bind. So what you have to do, you don't have to change any code. You just have to add the module java.xml.bind as part of your launch, your running of the Java runtime environment. So that's what you use, this add module. So you would just say add modules Java XML bind, and bam, works, no problem. If you need to do reflection, deep reflection on something that is a particular part of the Java library that is not imported, or actually it doesn't matter if it's exported or not. If you need to do any kind of deep reflection, then you would use this opens, add opens, and you would this is the easiest way to do it, is just to say, hey, okay, I'm in this module, I want deep reflection access to a particular package, so like java.util, or something like that, and equal, and afterwards basically saying, who am I giving that reflection access to? Well, easiest thing is just to say all unnamed. So basically give it, anybody who wants to read that, just let them do it. So most likely this is what you'll be using, is just all unnamed. You can actually give specific classes as well, but I doubt anybody's actually going to do it that way. All right, and then if you need to add an export, so like let's say that you're one of the unlucky folks who is dependent on sun.security x509 or something. Well, if you need to access that, you just have to say add the export. So you would say, all right, in java.base, add an export for sun.security.x509. Problem solved, no problem. Run it, and it runs just like it did before, doesn't complain. And that is going to work until you can actually get in and fix those dependencies. And coming soon is this kill switch that I mentioned earlier, this permit illegal access. I imagine that's probably what all of us are going to do, is just because you just put it in there and it's done. Basically, that bypasses everything that I talked about today. So all of the module protections, all of the hidden, and required and all that crap, all of that gets basically hidden, taken care of, satisfied with permit illegal access. So knowing that that basically breaks the entire point of modules, they are saying that it's only going to be available for Java 9, which is basically like, you guys better get your crap together like soon because it's not going to be around forever. So
But security wise, I mean, someone can always step back from Java 10 to Java 9 and be able to run.
yeah, I don't know how they're going to solve that problem. I don't know how they're going to solve that problem, but this is what they're saying at the moment.
New features in Java 10 that people just have to have.
Yeah. So I imagine there'll be loopholes. There's always a loophole. Okay, and then for JDEPs, these are some command line options. If you do a -S, it prints all the external jar dependencies for all the files in the current directory. -V will actually print all of the class level dependencies. So if you do a -V, you're going to get a ton of output because it's actually going to list every single class versus just a single jar. JDEPs -JDK internals, that'll tell you if you're dependent on like X509 or some internal com.sun class that you're not supposed to be dependent on. All right, so in summary, I'm finishing up here. This is a major change to the way that Java development is done. I mean, this is pretty much like took the whole thing and broke it literally into a bunch, 26 different pieces, right? And so now we have to do things differently. But this is, I think, a very a step in the right direction. I mean, I think this is a long time coming. Most mature languages do have the ability to do modules, so it's good that they finally added it. So it adds really strong encapsulation at the modular level, and most of your applications you'll be able to run on Java 9 without modification, but you may have to use one of the command line switches to get it to work. So just as long as you know what those command line switches are, it's not going to be a problem for you. When the IDEs add support, I imagine they're going to make this super simple to do. The module info Java file is what you're going to use to actually declare a module, to make your code, existing code modular. Like I showed you, it was one file at the top of the source tree, very little code, and boom, your code is now modular. The way that the module system has been designed is opt-in. So if you don't have the resources to modularize your code immediately, you don't have to. But you don't want to wait too long because eventually they're going to pull the rug out and you'll either be stuck running Java 9 forever or you'll have to migrate your code. Okay, that's all I got. Any other questions about things, any of the slides I want to go back to, you can take another look. This is recorded on Java YouTube, so if you wanted to go back and watch it again, you could. We'll also have the slides up on Fusion as well. So anybody, questions, concerns, gripes? All right, well, thanks for coming out. If you want to hang out afterwards and chat about any of this stuff offline, feel free. Otherwise, we will see you next time. Okay, here we go.